We'll now move on to logical operators. In Python, we have the logical operators and, or, and not. And these can be applied to comparison operators to enable you to make decisions in your program. Consider logical operators. These are and, or, and not. So we'll set A equal to 100, and here we'll do the following. We'll do the following checks. Is A greater than 1 and A greater than 3. So here, again, the result will be a Boolean, either true or false. And this will return a true if both the left-hand side is true and the right-hand side is true, then we'll get a true result. So for example, here A is 100 is greater than 1, so the left-hand side is true. A is 100, which is greater than 3, so the right-hand side is true. So with this AND logical operator, the result C will be true. As you can see. But, so for example, say we change the left-hand side to A is greater than 1,000, that would be false. So if either side, either the left-hand side or the right-hand side is false, the result of this AND will be false. So for example, A is not greater than 1,000, but it is greater than 3. So therefore the result will be false. It would equally be false if both the left-hand side of the AND the right-hand side were false. So here A is not greater than 3,000. So both sides are false. So with an AND, you need both sides to be true for a true response. So just to confirm this, so if A is greater than 1, A is greater than 2, both the left-hand side and the right-hand side here are both true, so therefore the result AND will give you a true. With OR, you get a true result assigned to C if either the left-hand side here is true or the right-hand side is true. So here, both the left-hand side and the right-hand side is true, so in which case we'll get true. Say we change this so the right-hand side here is false. Here we have the left-hand side is true, the right-hand side is false. So with an OR, because we'll get a true if either the left-hand or right-hand side is true, we'll get a true in this situation. You only get false if both sides are false. So for example, if we change this to 1,000, left-hand side is now false, right-hand side is false. So now when we print it, we get false. Not simply reverses. So for example, currently we've got a false answer. If we were just to say, apply the not operator, it just reverses that. So you end up with true. I recommend using brackets because it makes it more clearer, you know, what you're comparing. So by adding brackets, it makes it much more understandable. To just make it a bit more clearer how the not operator works, we'll set A to false. So this is A is a Boolean variable which has the value false. And if we print A out, we see false return to the output. If you was now to apply not to false, so A is now equal to the not operator applied to false, and you print it out, you get the value true. So false has been converted to true. Equally, if you set A is equal to not true, and you run this, you get false. We can summarize what we've just been going through by using truth tables. A truth table shows the result of applying logical operators to arguments, or in Python terms, what we call operands. So here we have a truth table for not. We have a an argument, or what's known as an operand in Python, and it can have the value true. And when not is applied to it, you end up with the result false. When a has a value false and not is applied to it, you end up with true. Below you have a truth table for the operator and has two arguments, a and b. When a is true and b equals true, and the and operator is applied to a and b, you end up with true. When a is false and b is true, and is applied to a and b, you get false. When a is true and b is false, your result will be false when and is applied to it. And when a and b are both false, when the and is applied to both the arguments, you will result in false. The truth table for OR is below. Similarly, you have two arguments, a and b, and you have a result for a having the OR operator applied to it with respect to b. So when a is true, b is true, the result is true. When a is false, b is true, you get the result of true. And when a is true and b is false, when OR is applied to it, your result is true. And when a and b are both false, when the OR operator is applied, your result is false. So truth tables make it a bit more clearer how these logic operators work. Finally, I'll just give you quite a complicated example just to show you how you can combine logical operators and comparison operators to make decisions. So here we have a float variable cost, which has a value of 106.5, a string variable product, which has a value phone, and a Boolean variable bin underscore paid, which has a value true. So what we have is a variable by, which is set based on the expression to the right. On the right hand side, we have covered in bracket, within brackets, a logical expression here. The brackets indicate this should be worked out first, and within this expression we're checking, is the cost less than 100 and is the product equal to a phone. The backward slash means this should be treated as if all this code is on one line, so it just enables you to have the next OR statement on the second line, but be treated as if it's all in one expression. And the OR here, which is checking whether the Boolean variable being paid is true. When you say OR being paid, is it similar as just saying OR being paid is equal to true? So what we're basically doing is checking, is the cost less than 100 and is the product equal to phone, or is it being paid equal true? So when we run this, we get the value true. Within the brackets, this actually results in false because the cost, 106.50, is not less than 100. So what's contained within the brackets, that logical expression there, is actually false, but being paid is equal true, so that results into true. So it's just an example of how you can combine operators to make complex decision-making statements. In the next lesson, we'll move on to identity operators.